Okay, so we just finished our discussion about various notions of type equivalence, and before we move on to some of the problems with structural equivalence, you should take some time to complete this exercise. Right? So here's a list of type declarations and variable declarations, and under these three schemes we'd like to know which variables have the same type. Right? So variables x, y, z, a, b, and c, which ones would be considered to have the same type under these three different schemes. So take a minute or two and sketch out your solution to all three of these cases, and this is something we can discuss in class on Monday. Alright, so what happens with structural equivalence? There's a few things that make this a challenging thing to implement in programming languages. Right? The first one is there's a few notions of ambiguity. Right, in this case we have two structures. They have the same types inside of them, an integer and a character, but the field names are different. So does this matter? Should we consider these to be the same type or not? So what you might do is consider why this might be an advantage to consider them the same type. What would be a disadvantage of treating them as the same type? Alright, one thing to consider here, if they're the same type, what happens when we ask for a field ch versus ch1? This seems like something that could be a little confusing. An advantage would give us a little more flexibility in the system, in that we could assign a variable of type 1 into a variable of type 2. Right? And so then we can also ask, how would type expression equivalence treat these? Would it see these as the same or as different? So I think it would see them as different because they are different expressions. The field names are different, and so they're not the same type expressions. Just that simple. So type expression equivalence just looks to see, is the type expression, the description of the type, are they the same or not? Here, they're just not the same. Now here's another form of ambiguity, and in this case the fields have the same name, but they're in different orders. So the question here is, does field order matter? Alright, so again, it might be an advantage to allow this to be considered the same, and that we could move a variable of type 1 into a variable declared to have type 2. We'd have to do some shifting around of the layout perhaps, or the way we reference fields needs to something we can't do statically, that we don't always know that the integer is the first thing or that the character is the second thing. And so this is something that gives us some flexibility, but may take away the static offsets that we can compute when we don't have to switch field orders. So this is another one that something we genuinely probably would disallow. Right? And again, type expression equivalence here would treat these as different because they are different expressions, different type expressions. Alright, so this sort of gets to our question about layout decisions we hinted at a minute ago here, right? That if we do allow this to be the case, what is val1 of x? Right? How do we look this up? And can we do this in a static? Can we do this in a constant amount of time, or do we need to keep some extra data along with the field values that tells us where to look up particular fields? Right, so this is something that certainly is not very appealing. And another thing that can happen here is this notion of circular types. Right? So in this case, here we have two C type defs for structures to specify linked lists, and they're the same except for the names, but the types are circular. Right? So the definition of a cell 1, right, this type says we have some type cell 1 here that we're defining. One of its elements is the list pointer, and the list pointer is defined to be this cell pointer. List 1 is a pointer to cell 1 structures. Right? So this is something that's a little tricky. So question here is, what would type expression equivalence do? So type expression equivalence is where we're going to replace the user-defined type names with their definitions. And so how can we do this recursively, right? We sort of keep replacing, for instance, list 1 with a pointer to cell 1. We could do that, but then we have to replace pointer to cell 1 with its definition, which would be the structure surrounding it, right? So we'd be doing this repeated unfolding of the definitions that wouldn't terminate. So type expression equivalence certainly doesn't work in this case. Right, so most languages then avoid all these sort of problems we've had with structural equivalence, such that if they allow it, they can short-circuit this strict definition of type expression equivalence, and they sort of prevent one from doing things like this. C, of course, if we give them the same name, if we have this two variables that are declared to have the same structure with the same structure name, then there is the same type. If they have different names, we see them as different types. If they have no name, they are also seen as different types. So the structural equivalence seems appealing, but comes with a few challenges. All right, we're going to pick this up with some more discussion on type checking in the next video.